Hello everyone, I am Chaturya. I am currently pursuing my fourth year Electronics and Communication Engineering from SV Engineering College Tirupati. Current, I am doing internship on IoT along with my teammates Ashwan Sai and Sai Bhavana. During this internship, we built a project home automation based on IoT. In this presentation, I am going to explain these contents. The contents contain abstract introduction, embedded program, project requirement, application, project, design component, application, conclusion, and references. Now I am going to explain the extract of this project. The main objective of this project to develop a home automation system using an Arduino IDE with using PixSimLab and Blink IoT app. As technology is advancing, so houses are also getting smarter. In order to achieve this, PixSimLab is interfaced to Arduino IDE with the using of serial port emulator. A Blink IoT application on the cell phone sends on or off commands to the where loads are connected. By touching the specified location on the Blink IoT, the load can be turned on or off remotely through this technology. Now I am going to explain the introduction of this project. In these 4 weeks of internship, it's my gratitude to learn about different software systems under such a great and helping nature mentors, mainly IoT, embedded system, C programming, C++ programming languages are learned and using that run the different projects. Now, what is IoT? Internet of Things. The Internet of Things describes physical objects with sensors, processing ability software, and other technologies that connect and exchange data with other devices and systems over the Internet or other communication networks. Now, the applications of home automation. What are the applications involved in home automation? Improvement of productivity, low cost, improve customer services, save effort and time. Now, what is embedded system? Embedded system is a combination of computer hardware and software designed for a specific function. In short, it is a combination of processor, computer memory, and input or output peripheral devices. For many embedded systems, C and C++ will be best choice. Now, there is a figure related to embedded system that is shown in the page. Now, I'll say about C and C++ programming. It is a programming language which has been used for game programming, software engineering, data structures, operating and applications, etc. Now, what are the data types in C? The data type is given here and the size of each bit is represented and the range also is represented in the table. Look at the table that is present here. Now, what are the requirements and applications that are needed for this project? Arduino IDE, PixSimLab, and serial port emulator, Blink IoT application. Now, what is this project? In this home automation project, we use Arduino IDE, PixSimLab simulator, and Blink or Android application. This home automation project contains measurement of temperature, indication, odd water level, and control golden lights. First, we started with Arduino IDE to implement the code of various sensors. We have various code which we require in this project. After implementation of the code, we need software so we can run code and get output of the code. So using PixSimLab, we get the output. We used serial port simulator which connects Arduino IDE and PixSimLab. We use Blink Android application in our smartphone to remotely control our project according to user. We also get notified via blank application. Now here is the source code for the home automation using Blink. The description is to control lights brightness with brightness, monitor temperature, monitor water level in the tank through the Blink app. Peripherals used is Arduino UNO temperature system, LED, LDR module, serial tank, Blink cloud, Blink app. Now I'll show the source code of the home automation. To turn on and off outlet value based virtual switch value. Look at the source code of the home automation. Now the components of this project is explained by my teammate Sai Bhavana.
I am Sai Bhavana. Now I am going to explain about design components. Firstly, we will see about W5500 Ethernet sheet. The W5500 Ethernet sheet can provide our projects with internet connectivity. W5500 enables users to have the internet connectivity in their applications by using the single chip in which TCP or IP stack 10 or 100 Ethernet MAC and PHY embedded. The shield also has two Grove connectors and a micro SD card socket to support projects which require storing large amounts of data from Grove sensor. The RJ45 port is low enough to allow you to stack more shields on top of one of these if needed. The features are it supports hardwired TCP or IP protocols such as TCP, UDP, ICMP, IPv4, ARP, IGMP, etc. It also supports 8 independent sockets simultaneously. It supports power down mode. It also supports a wake on LAN over UDP. It supports a high-speed serial peripheral interface. Now let's see about temperature sensor. The temperature sensor LM35 series are precision integrated circuit temperature devices with an output voltage linearly proportional to the centigrade temperature. The LM35 device has an advantage over linear temperature sensors calibrated in Kelvin, as the user is not required to subtract a large constant voltage from the output to obtain convenient centigrade scaling. The LM35 device doesn't require any external calibration or trimming to provide typical accuracies of plus or minus 1 by 4 degrees centigrade at room temperature and plus or minus 3 by 4 degree temperature over a full minus 155 degrees centigrade to 150 degrees centigrade temperature range. And its technical specifications are calibrated directly in Celsius, zero point 0.5 degrees centigrade ensured accuracy, suitable for remote application. Next, we look into a light-dependent resistor. A light-dependent resistor is also called a photoresistor or a cadmium sulfide cell. It is also called a photoconductor. It is basically a photocell that works on the principle of photoconductivity. The passive component is basically a resistor whose resistance value decreases when the intensity of light decreases. The optoelectronic device is mostly used in light varying sensor circuit and light and dark activated switching circuits. Some of its applications include camera light meters, street lights, and outdoor clocks. Its advantages are LDRs are cheap and are readily available in many sizes and shapes. They need very small power and voltage for its operation. Its disadvantage is it is highly inaccurate with a response time of about tens or hundreds of milliseconds. Our next component is light emitting diode, which is shortly known as LED. The LED consists of two terminals such as anode and cathode An anode is a positive terminal and we can connect the positive terminal of power supply to this terminal. Similarly, we can connect the negative terminal with the cathode. While using an actual LED, we can find cathode and anode terminal in two ways. The first way is the longer lead always an anode terminal and the shorter one is a cathode. Second way is we can identify cathode from the flat surface and another one with anode leg. Next, our component is liquid crystal displays. The liquid crystal library allows you to control LCD displays that are compatible with the Hitachi HD44780 driver. There are many of them out there and we can usually tell them by the 16-pin interface. The LCDs have a parallel interface, meaning that the controller has to manipulate several interface pins at once to control the display. The interface consists of following pins: a register select pin that controls where in the LCD's memory you are writing the data to. We can select either the data register, which holds what goes on the screen, or an instructor register, which is where the LCD's controller looks for instructions on what to do next. A read write pin that selects a reading mode or a writing mode. Next, our component is I2C. I2C is short for Integrated Circuit, a synchronous serial communication protocol developed by Philips for communication between a fast microcontroller and relatively slow peripherals using just two wires. Hence, it is sometimes also known as TWI, that means to a two-wire interface. The I2C bus. The I2C bus consists of two wires called the serial data and the serial clock. Data is transmitted through the SDA line while the SCL line is used to synchronize the devices with the clock signal. Both these bus lines are open drain drivers and hence you have to use pull-up resistors to keep them high. The major three applications of this project are: through this home automation project, we increase or decrease the room temperature according to the user comfort. Second, with the help of Android application, when water tank fully fill, it notify user. And the last one, by using LDR sensor in this project, we can control our garden lights. Now the output will be demonstrated by Ashwant Sai.
Hi, this is Yashwant Sai. Now I am going to show the output of our project using PiximLab software. PiximLab software. This is the PiximLab software we have used in this project, and this is the Arduino board. And these are the internal peripheral devices in the Arduino board. And this is the resistor which indicates the brightness. And when the resistor is decreased, the light will turn off. When the resistor is increased, the light will be turned off. When the resistor is increased, the light will glow. By increasing resistance, it means the darkness is increasing. When the darkness is maximum, the light will glow. And these are the other devices used in this. And this is the blink app we have used in this. And in this we have two tabs. In tab 1 there is a heater. If we on the heater, the temperature will be increased, and in CLCD it will show heater is on. And when the temperature is reaches 35 degrees Celsius, the heater will be turned off. And in notification it will show the temperature is above 35 degrees Celsius, that means turning off heater. When we turn on the cooler will run and the temperature will be decreased. In CLCD, the cooler on will be showed and the temperature is decreased to 27 degrees Celsius. And when the heater is on, the temperature will remain constant. If cooler is off, the temperature will increases. And cooler off shows on the LCD screen. This is the indicator which indicates the temperature. And when it reaches above 35, the heater will automatically turn off. And when the cooler is on, the temperature will decrease to 27 degrees Celsius. And this is the cereal tank which is used to control the inflow and outflow of the water tank. In tab 2 there is inlet valve and outlet valve. Let me show that practically. Initially, let us assume that tank is full and the volume is 3000. Let's on the outlet valve. Now the volume will be decreased. You can see here. And when the volume reaches below 2000 and the inlet valve directly on, and in CLCD it will show inflow on and the volume remains constant when inlet valve is on. When outlet valve is off, the volume will be off. When the volume reaches 3000, it will automatically turn off. The inlet valve will be turned off. And in CLCD it will show inflow is off. In tab 1 we have notification, it will indicate water level is full. Water inflow is disabled. Now let's on the inlet valve. It will automatically off. When we turn on the outlet valve, the volume will be decreased. And in this indicator we can see the decrease of the volume. And when volume reaches below 2000, automatically the inlet valve will be on. In tab 1 we can see the notifications, water level is less than 2000, water flow is enabled. It is the indicator, it indicates the volume of the tank. When the two valves are on, the indicator will be constant. Now let's see the interface of the Blink app. This is the interface. By clicking Home Automation, we can access these two tabs, and this is the final output of our project. As you can see, we can control the temperature, we can turn on or off the lights. Now let's see the conclusion. The main purpose of home automation is to provide easy lifestyle via to control different home appliances with the help of an Android applications which is easy available in smartphones. With this we can save electricity and time and money. Thank you.